Welcome back to our exploration into trigonometry. We're going to be focusing on the polar coordinate system for today's lesson. The polar coordinate system is this circular coordinate system that you see here. We have been dealing with the Cartesian coordinate plane, which is the rectangular coordinate system where we have the x and the y axis that meets at the origin. The polar coordinate system also meets at the origin, which we call the pole, here in the center. And the polar coordinate system consists of a ray, which we call the polar axis, which is straight out, like you would have the positive x-axis. And then each point that is on the plane, somewhere on the plane, can be described by an ordered pair. Just like in the rectangular coordinate system where you have an ordered pair that tells you where the x and the y locations are, this tells us the r and theta. R is the directed distance from that pole, so how far away the point is from that origin pole, and theta is the angle that is made with the polar axis. So if you see this drawing right down here, you can see that we've got the pole, which is our origin, and then our polar axis, which would be like the positive x-axis. The r is the distance of that point, and then theta is the angle measure. The first point in that ordered pair is the distance of r, and the second is the measure of theta. We have three possibilities for r. R can be positive, r can be negative, and r can be equal to 0. If r is positive, then P is located r units from that pole, the center origin, in the direction of theta. We're going either clockwise or counterclockwise depending on the sign of theta. If r is negative, then P is located, absolute value of r units. So if we had -3, then r would be 3 units from the pole in the direction of theta plus pi. So it actually winds up being 180 degrees from what the angle would be. So if your theta was pi over 6, you would be doing pi over 6 plus pi, and you would get 7 pi over 6 instead. If r is equal to 0, then P is located at the pole because there is no distance. The point r is not extended anywhere, it is just at the pole. Theta is the angle from the polar axis to the line that is drawn, OP. If you see down here, this OP line. So what is this theta? Just like in the unit circle, when you are positive, when theta is positive, you're going counterclockwise, and when theta is negative, you're going clockwise. Being that we're dealing with circles in our polar coordinates, thinking of the unit circle, anytime you do a revolution of 360 degrees or 2 pi, you're back to the same starting place. Ordered pairs for r theta and r theta plus 2n pi represent the same points on the polar coordinate system. These are the same polar coordinates for any n that is an integer. Remember, this is saying n is an element of z, and z represents the integer number system. Another way that we could write this is, remember, if r is negative, we're saying theta plus pi. So we could say that the ordered pairs r and theta and negative r and theta plus 2n plus 1 pi are the same point. The reason that we're saying 2n plus 1, that's going to give us an odd value. It's not at every pi that we're repeating, it's every 2 pi. And since r, when you are negative, is the same thing as theta plus pi, then it's every 2 pi after that. So we have theta plus pi, theta plus 3 pi, theta plus 5 pi. So you need the odd version, which is where the 2n plus 1 comes from. One thing we want to be able to do is convert between polar coordinates to rectangular coordinates and between rectangular coordinates and polar coordinates. Let's look at this rectangular coordinate system that we have drawn on the right, where we've got some value for x and y. So that's the value for x. We've got this y value here. We have an angle theta, and we have this distance r. This is the ordered pair r theta. It's also the ordered pair xy. Because r is that distance, that's the hypotenuse, which we know how to calculate using x and y. And then theta is the angle measure that happens. Well, recall the definitions that we were using when we had x, y, and r. We could say that the cosine of theta was equal to x over r. The sine of theta was equal to y over r, which we could then rewrite as saying x was equal to r cosine theta, and y was equal to r sine of theta. Well, how do we find r? And how do we find theta? In this case, if we are given x and y, we can find r by using the Pythagorean theorem. X squared plus y squared equals r squared. And then if we wanted to find theta, we can use x and y, and they're related by tangent. But we know that the tangent of theta is equal to y over x, which we could then say theta is equal to the inverse tangent of y over x, and r is equal to the square root of x squared plus y squared. Now we have a way to go from polar to rectangular and rectangular to polar. If you're given x and y, then you're going to use this here to get polar information. If you're given theta and r, you use this information to find your x and y. It should be noted that in the examples that we're going to be doing, we're going to have theta in radians. Sometimes we have equations that are easier to solve in polar coordinates than they are in rectangular coordinates, or vice versa. And so we can convert an equation that's in polar coordinates into rectangular coordinates, and we can convert an equation in rectangular coordinates into polar coordinates. So if we first want to convert from rectangular to polar, we're going to use the fact that x equals r cosine theta and y equals r sine theta. You want to substitute x equals r cosine theta and y equals r sine theta, and then solve for r. Converting from polar coordinates to rectangular coordinates might be a little bit more daunting or challenging. You would want to use one or more of the following statements: that x equals r cosine theta, or y equals r sine theta, or x squared plus y squared equals r squared, or the tangent of theta equals y over x. Remember, when x doesn't equal to 0. And you can use them in combination, or you could use just one of them. It depends on the equation. You could also multiply both sides by r, or you could then square both sides of the equation. So it just depends on the information that you are given when you are converting from polar to rectangular. That's it for this section. Head over to the skills practice to see conversions between polar and coordinates, plotting polar points, and converting equations from rectangular to polar coordinates or polar to rectangular coordinates.